asking questions. Thank you for doing work. Thank you. That makes me very proud. Okay, so let's start with 58. Okay, let me share my screen. So let's find 58. And it's 58, I'm sorry, I forgot to ask, is it from the same section or a different one?
Yeah, same section.
Okay, 48, 58, 53, 58. This one, right? Yes? Okay, so limit as x approaches 0 from the right, tangent to x, and everything raised to power x. Perfect. Okay, great job. So 0, tangent to x, when x approaches 0, tangent to x approaches 0. And this approaches 0, so 0 raised to 0 is an ugly situation. It's one of the powers. Indeterminate case, we don't know what this will come out to be. So because we have a function raised to another function, we denote the function. So this is step number 1. This is the long procedure for this. So y equals tangent to x raised to x. In step 2, we apply natural log to both sides. Now let me stop here. Do we understand this step and everything I wrote, or do we need to look at an intermediate step?
No, I think we're fine.
Okay, thank you. So now in step 3, I apply limit to both sides. So I have limit of natural log y as x approaches 0 from the right equals limit as x approaches 0 from the right from x multiplied by natural log tangent to x. Okay, now I check again. So this approaches 0, and this approaches 0 from the right, which makes natural log approach negative infinity, because natural log looks like this. 0 from the right, negative infinity. I don't care about the sign. It's 0 times infinity. So I'm looking for an algebraic manipulation. And no, I'm not going to touch the ugly one. Of course not. I'm going to change this like we just did a minute ago. So I have x. I'm going to write 1 over x. Or 1 over x to negative 1. Same thing. So I'm going to flip it to the bottom. So this one stays in place. Too complicated to go anywhere. We want to simplify our lives, not make it more difficult. So x approaches 0 from the right. So natural log of tangent to x over 1 over x. 1 over 1 over x is x. I check again. Of course this doesn't change. Infinity, negative infinity, who cares? 0 from the right, remember the graph of this. We did all these graphs, we looked at all these graphs many times before we even started, because I need those graphs for 1 over x, and this is natural log x. So this is infinity. A sigh of relief. So this is limit as x approaches 0 from the right. This one is nice. This one is ugly. 1 over tangent to x times secant squared 2x times the inner function prime. Okay, so now let's see what happens here. Still ugly looking. 0 from the right, this is not a threat, because it's 1 over cosine, so it's 1, and this is 2. This is a threat, and this is a threat. Okay. So I'll take the 2 outside. I will drop this one for a second. Let me think for a second if I bring that. So let me write the 2 in front, the limit as x approaches 0 from the right. It's negative in front, so I can take care of that. X squared goes to the top. Tangent to x goes to the denominator, because I divide this fraction, I keep it as is, and I flip this, and the minus and the 2 in front. This bothers me. I'm going to leave it on the side for a second, and then I've explained what happens here. If I keep these two, and continue, obviously it's 0 over 0 again. So if I keep this function here without thinking that this approaches 1, and I can drop it, the numerator will become quite complicated. I will have to differentiate a product. And this will, at the end of the day, will not have an impact on the answer. We can do both if you want, but I can drop it because it will approach 1. It's like a constant at this point. So I will do that. I will continue. Yeah, these ones, the powers are not very friendly, obviously. So we'll continue with -2 and limit as x approaches 0 from the right. The numerator is still, so it's still 0 over 0. So the numerator is 2x. The denominator is secant squared 2x times 2. And this approaches 1. This will simplify, and this approaches 0. So the whole thing is 0. If I had kept the secant squared, in case you're asking, then I would have differentiated this as 2x times secant squared 2x plus x squared times 2 times secant 2x times secant 2x tangent 2x times 2. So what would have happened, this would have approached 1, this would have approached 1, this would have approached 1, this would have approached 0, and this is 0. So still I get the same thing. So the fact that I simplify the function like I did with the 2, I put the 2 in front, it's like I'm applying the limit from this and I'm taking it in front, it didn't make any difference because it's 1. But if it were 5 or 10 or something, I would have put it in front. If it approached 0, I would have never touched it. It has to stay in the problem. But it approaches 1 or a constant, so I can take it in front, like I did with 2 or -2. So the answer is 0, but this is not done. Because now remember, in step 4, I have to copy the beginning and the end to make a conclusion, draw a conclusion about the limit that I'm really, really interested in. So I'm copying the beginning of step 3. So this is step 4. X approaches 0 from the right, from natural log y equals 0, or limit as x approaches 0 from the right, from natural log of tangent 2x raised to x is 0. We swap these two, and I have limit under conditions of continuity, the theorem that allows us to do that. So limit as x approaches 0 from the right, from tangent to x to the x power. We conclude that this must equal, anyone?
Is that from the 0 from last time?
So I put the 0.
Oh.
So how much is this? So limit as x approaches 0 from the right, from tangent to x to the x power.
Is it 1?
Thank you very much. Only natural log 1 is 0. Thank you. Or e to 0 equals this. Same thing. Whichever you prefer. E to 0 equals a natural log. But e to 0 is 1. So, not natural log, limit, sorry. The limit as x approaches 0 from the right. So that's why the limit is 1. Oh, I'm sorry, there was one more. I'm sorry. Okay, so now we're looking at 36 in 4.3. Let me share my screen. Okay, 4. So this was 4.4. We go to 4.3. 36. Great job, okay? So let me copy the information. Okay, it says, so this is 36. A vertical asymptote at x equals 0. F prime of x is positive for x less than -2. F prime of x is negative for x greater than -2. Of course, not equal 0. The second derivative, where is it? Okay, less than 0 if x is less than 0, and the second derivative is positive for x greater than 0. Perfect. Okay, I'm going to stop sharing. Where's my mouse? Here. Okay. Good. Again, I recommend summarizing everything so you don't make an error. That's my suggestion always. Okay, so vertical asymptote at x equals 0. Okay, next, less than -2. The first derivative is positive, less than -2.
I think somebody in the chat wanted to know if you're recording. I don't know if you saw that.
Yes, I am. I'm 12 minutes into the 4th video. Yes. Thank you. Yes, thank you. Thank you for reminding me. I had glitches in the past, so it's always good to remind me. Okay, so this was taken care of. This was taken care of. Negative for greater than. This was taken care of. The second derivative is less than 0 for x less than 0. This is taken care of. You don't have to cross them out like that. You know what I mean. I'm making a point. Okay, so this opens up. So obviously for me, this will be a local max because the function will be increasing on this area and always decreasing. So here is my graph. It has a vertical asymptote x equals 0. It opens down and it has a local max at -2. So it's increasing, and then decreasing. Okay, so this is what I want. So it's increasing, opening down, increasing to -2 comma whatever you want to put in here, doesn't matter. I don't even care what it is. And then it's decreasing, opening down to whatever. On this side, it's always decreasing, opening up. Always decreasing, opening up. And keeping in mind that x equals 0 is a vertical asymptote. Is this better?
Yes, thank you.
Perfect, anytime. Next question.
On the test that you put in, I know you added the answers, but I think the answers are for a different test. So I wanted to see if we could do question number 2.
Yes, any question? So question number 2 from the previous test.
Yeah, from the test that doesn't have answers.
Okay, let's take a look. test 3, old test 3, the one that says old test 3?
Correct.
Okay. And you said question number
Number 2.
Okay, find the critical numbers. Very good. So we have h of t equals t to 3/4 minus 9t to 1/4. Good. So obviously here t has to be greater than 0 or equal to, because this basically is the 4th root of t to the 3rd. This quantity has to be positive or 0. And this is the 4th root of t. This quantity has to be positive or 0. So this is the domain of this function. So h prime of t, 3/4 t to 3/4 minus 1, negative 1/4, minus 9/4 t to 1/4 minus 1, which is negative 3/4. I will factor out 1/4 and also 3, actually 3/4, and t to negative 3/4. Because of these two, the smallest power is negative 3/4. So, negative 1/4 minus negative 3/4, right? So from negative 1/4, we subtract negative 3/4. So we have 3 minus 1 is 2, 2/4 is 1/2. So the square root of t minus 9. Or 3/4, the square root of t minus 9 over the 4th root of t to the 3rd. So t equals 0 is not a critical number. Why? Because the function, sorry, it is a critical number. The function is defined there. As long as the function is defined, it is a critical number. Sorry, I rushed before I looked again. It's good that I always check myself. Sometimes I miss. Anyway, so, and then the square root of t minus 9 equals 0, and the square root of t equals 9, so then we have to square both sides, so then t equals 81. So t equals 81 is the other critical number. So one coming from h prime being undefined. That's why I wrote that, and I almost missed it, but I got into the habit of checking. So the function is defined at 0. Because it's defined at 0 and the derivative is not defined at 0, this becomes a critical number. And it may not create a max min local because it's at the end point of the interval, but it doesn't matter. I have to identify it as a critical number. It's mandatory. And then the other one, t equals 81.
Thank you.
Thank you. Good. Next question. Very good question.